Welcome to Tableau. Tableau is a tool that we use to perform data analytics. It helps organizations be more data-driven, and as we use Tableau, we need to realize that there are a variety of other applications that we could use while to perform data analytic processes. Tableau is one of many tools that can be used to perform data analytics and data visualizations. Now, when you think about Tableau, we need to realize that Tableau is not just a tool, a software. It is actually part of a larger ecosystem of products that exist. And so Tableau is rather a platform rather than a specific product. There are a variety of add-on products that go along with Tableau. How does SQL work with Tableau? SQL allows us to interact with data. However, Tableau is a tool that allows us to see and understand that data, to visualize what might be actually stored in a database. Now, this fits very well with organizations that want their analysis and decisions to be more data-driven. Tableau allows us to create a variety of different types of data visualizations. These data visualizations range from maps to line charts to bar charts. And so there are a variety of different tools that we can use for Tableau. Now, to use Tableau, for our purposes, we're going to be using Tableau Students. And you can download that from the website that's provided as part of the slide deck. To start off with, let's start by opening up Tableau. When you open up Tableau, at least in this case, you're seeing a lot of different workbooks. However, you should not see many workbooks in your Tableau environment when you first open it up. You should typically see like 3 sample projects in the bottom. On the left-hand side, you'll see a variety of different data sources that Tableau can connect to. If you click on the More button, you'll see a lot of the additional connectors that Tableau has that allows it to connect to other data sources. Now, for the purposes of this class, you can find data that we'll be using, for instance, in the data submodule, the MySQL database data submodule that is present on ELC. Most of the data files present over there are CSV files. Some of them might be Excel files that Tableau can also connect to. While you might see MySQL server connection over here, we aren't actually going to connect to the MySQL server. We're going to actually use the CSV files that hold data from the classic models database. Any workbooks that I create will be actually uploaded into the workbook submodule. To start off with, let's connect and find the text file. Download the text file, Central Park Temperatures, somewhere locally in your computer. And once you've done that, you can actually find that file on your computer and actually open it up. So download Central Park Temperatures, find it, centralparktemps.txt. Go ahead and open it up in the Tableau environment. So when Tableau opens it up, you can see some information about the file. You'll see some fields. You'll see some sample data, and notice that it's showing you only the first 100 rows of data. The data file might actually hold multiple rows. In this case, 1,765 rows with 3 different columns. You'll find information about the files in that white space up there where you see centralparktemps.txt. Now, to make a worksheet, what we're going to do is we're going to click on sheet 1, which is the default first sheet that is present. Now, on the left-hand side, you'll see information about the fields that are present. You'll see Central Park temps. You'll see the different fields, in this case, month, year, and a measure associated with the month and the year. In this case, temperature. Now notice right next to month, year, and temperature, we have a hash mark. That hash mark represents the data type that is associated with those specific measures and dimensions, right? So we have month, year, and temperature, and the hash mark represents the fact that each of these, as they're coming into the Tableau environment, are considered to be numeric data types. Now, Tableau takes these fields and associates them with what is called dimensions and measures. Dimensions tend to be categorical data versus measures tend to be numerical data. Now, if you want to change the data type, in that case, we can click on that hash mark. So it's, Tableau is considering month and year to be numerical measures. We know that month and year are in fact not numerical measures. Month and year should be considered like date time or date type measures, time type measures. And so we can either change the data type or you can click on the hash mark. So in this case, I want to change the data type and make that date type. And I'm going to do the same for year, but notice that the icon right next to month changes and it'll also change for year as well. So if you click on the hash mark next to year or click on the down arrow next to the year pill, you can change the data type to be date type data. Now what we want to do is, the first thing we want to do is kind of build kind of a crosstab of the different years that we have in our data set and the different months that we have in our data set and represent the temperature values for them, right? So we do this by dragging and dropping the different pills. In this case, I'm going to drag the year pill, just select, drag and drop the year pill into kind of the rows. And notice that when you do that, the way Tableau represents it is you're going to see along the rows and columns, you're going to see year of year and year of month, right? Now what Tableau is doing is it's looking at the year pill and it's converting it into what we like to call, it's treating year as a continuous variable, right? And what we want to do is we want to change that. So there are a couple of different things that we can use to change that. We can actually change it from continuous. As you can see, the continuous is checked down there. We can change it from continuous to discrete, or we could also select the other option associated with year. So in this case, just select discrete. And so notice that we go from being a green pill, which is kind of a continuous pill, to being a blue pill, which is kind of considered more discrete. For month, instead of looking at the year of the month, we're actually again going to convert this to discrete. Now, that actually makes the year of month look at 1900. What we want to do is, we don't want to make that discrete, but that's because we have that year check mark. We're going to change that to month. And so we have all the different months of the year, right? So, the month is represented as 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. And so we've changed that to be represented from January to December. Now take the temperature pill and drag and drop the temperature pill to the values area. And so now we have over here a crosstab of year and month and the temperatures for specific years and specific months. And so these are temperatures in Central Park associated with that. This is our first sheet that we're making. We can rename it. We can call it a crosstab of year, month, and temperature. Now we'll be making a second sheet. In this second sheet, what we're going to try to represent is we're going to represent year values, and we actually want to represent temperature, but we want to represent temperature in a different unit. And so the first thing we need to do is we need to look at what unit temperature is in right now. If you scroll through all of this, you'll notice that the values of temperature over here that we have are in Fahrenheit, and so we want to change that. We want to, for instance, maybe represent the temperature in Celsius. And so what we're going to do is we're going to create a calculated field, right? And so Tableau allows us to create calculated fields, and this is going to be temperature in Celsius. The formula to create temperature in Celsius is to take the temperature that is we have, that is present in Fahrenheit, and from that value of temperature, we subtract 32. Now, we want to surround these in parentheses, and this temperature, subtracting 32, we multiply that by 5 divided by 9. So we're going to create a new column, a calculated column, and that's temperature in Celsius. And so you can see we have this new calculated field on the left-hand side, temperature in Celsius, which is now going to be used. And so we're going to display the year. We can click on the down arrow next to the year pill and again make this discrete. And so we're going to then take the temperature in Celsius and drag and drop that pill into the values area. Now notice that these values are really, really large, and that's because it's summing up those temperature values for those years. And so we want to change that. And so instead of the sum of the temperature in Celsius, we can click on the down arrow next to sum of temperature in Celsius and change that to the average, right? So that gives us the average temperature over time from like 1869 all the way to where, what we have right now. Now, in addition to the temperature in Celsius, what we're going to do is we're going to kind of create a few other fields, right? We might in fact want, for instance, maybe the maximum, we might want the minimum, right? And in this case, notice that we don't have really the, what we want to do is we want to take the temperature pill and add it to the values, once again, giving us two columns, one with the average temperature and one with the minimum temperature. And so basically that's taking the temperature in C and dragging it onto where those values are. We can do that once again, and instead of doing average, minimum, sum, we'll do average, minimum, maximum. And so we have the year, and then we have the minimum temperature in Celsius, and we have the maximum temperature in Celsius for this data set starting in 1869. Now, we can change the name of our sheet. These are basically summary statistics for temperature. Now notice that whatever we change our name of our sheet, the header inside that sheet also changes. And that's what we have going on here. Now, what we're going to do is we're going to create a third sheet where again we're going to work with year and the temperature data, right? The temperature in Celsius. Again, we are making this year continuous. We're going to take temperature in Celsius, drop into the values area, convert that to be the average temperature once again. And so we have the year temperature. Now, what we can do is we can take this data and make this a line chart, because line charts are great for displaying data over time. So click on Show Me, and then it displays the different options that you have, one of which is the line option. So you can select one of those line plots. And what happens once you select the line plot is you will see the change of temperature over time. So you have your y-axis, average temperature in Celsius, your x-axis, which is year, and then you have the change of temperature over time. Now, one of the things that you should be paying attention to as you look at this chart is this sudden change that happens in the last observation, right? In that last observation, you see the value of temperature suddenly drop all the way down. Question is, why? If you take a look at, for instance, the crosstab data, you will notice at the bottom, 2016, we have only one observation, the observation of temperature in January. Now, if we want to fix that, you'll notice that in 2016 we have that same average that shows up for all average, minimum, maximum. So that's why we have that erroneous observation. Now, one thing we can do is we can just exclude it from our visualization. You can just select that dot and exclude it, which is basically a filter, right, that we're going to be creating. So what you can do is you can select the year tool and drop it onto filters, and you can select the specific year you want to filter out, right? So you can click on next, and you can say, hey, you know what? I want to select all of these observations or none of these observations, right? So if you click and apply, select only 2016, you will see only that observation, right? And you can either exclude that observation or you can include all other observations and exclude just that one, right? And so you see this line chart, and that observation is excluded specifically from this line chart. Now that means that that observation is going to be present in the other charts that are present, and you can decide if you want to exclude those observations for those charts as well.